Okay, so let's now start today's problem solving. Let AD, B, and CF be the altitudes of a triangle ABC with circumcenter O. Prove that the circumcircles of AOD, BOE, and COF intersect at a point other than O. So now it comes to a new question, proving that three circles meeting at one point. So our method is to prove that to find the intersection of the two circles and prove that it lies on the third circle. So it is also used in this problem. So here, if we denote the three circles as omega 1, omega 2, and omega 3. So I only drew the two circles omega 1 and omega 3. So denote the circumcircle of BOE equals to is omega 2, right? So we try to find that OX is the radical axis of the three circles. First, we need to notice one thing. OX is the radical axis of the two circles, omega 1 and omega 3, right? OX is the radical axis of omega 1 and omega 2, omega 3. So what can we do next? Since AD, BE, and CF are the altitudes, then we know that they meet at one point, H, which is also center, right? So now we can discover one magic thing, or here, if we connect the 2 points O and X, we might find that H lies on OX. Then we try to prove that H is also on the radical axis of omega 1 and omega 3. Why does it hold? We know that A, C, D, and F are concyclic. That is very obvious. So we know that HD times HA equals to HC times HF, right? Which means the power of H2 omega 1 equals to power of H2 omega 3. And then that means H lies on the radical axis of omega 1 and omega 3, right? So which shows that O, H, and X are collinear, right? So we only need to prove that OH is the radical axis of of both omega 1, omega 2, and omega 3 and omega 2. So notice one thing. Easily we can get we can do this like power of H to omega 2 equals to HB times HE equals to HA times HD equals to power of H2 omega 1 also equals to HC times HF equals to power of H2 omega 3. And that shows that H lies on the radical axis of the two circles, the omega 1 and omega 2, omega 3 and omega 2 respectively. So since O also lies on the radical axis of the two pairs of the circles, then we know that OH is the radical axis of omega 1, omega 2, and omega 2, omega 3. And this shows that OH is the radical axis omega 1, omega 2, and omega 3. That is very easy to find, because when we get this conclusion, we also have and also omega 1 and omega 3. That's the original thing we have. So after that, what can we get? You might find that the problem is solved because X lies on OH. OH is also the same thing it's the radical axis of the three circles. So and plus power of X to omega 1 equals to power of X to omega 3 equals to 0, since X lies on the two circles. And then X lies on omega 2. That is very obvious, right? So then we have proved this problem, because X is obviously different from O, and we have proved that X lies on omega 2, and it is of course it is the intersection of the three circles. And then we have proved this problem. So that's the end of this problem. Thank you for watching.